This is the second video of Section 8. Section 8 is how to name chemicals. And we're going to switch from just naming ions to naming binary ionic compounds. And in this video, we're going to go from the chemical name to writing the formula. And we're only going to do it for monoatomic ions in this video because that's easier to start with. And once you understand how to do that, it's easy to transition to polyatomic ions. So you need to remember that bi means two. And you're aware of this because a bicycle has two tires. A biped is an animal with two legs. And so a binary compound is going to have two components. Once again, we're going to be dealing with binary ionic compounds in this video. And so let's take a hypothetical compound, JQ. The two components are J and Q, where J is the cation and Q is the anion. And as I said, we're going to be dealing with monoatomic ions because it's easy to start with. So when you take a look at this separation into the two components, it turns out that J, the cation, will always be a metal, and Q, the anion, will always be a nonmetal. So there are your two components, metal and nonmetal. And there are two general rules for naming any ionic compound. The first is that a cation always goes first, and the overall electrical charge of the entire formula unit must equal 0. The total positive charge must equal the total negative charge for each formula unit. So we're going to be going in this video from the chemical name to the formula. And this is a stepful procedure. And there are 4 steps you're going to have to follow, and I'm going to elucidate the steps utilizing 3 examples. And the first example will be cesium bromide. So your first step is to find the symbols on the periodic table. So here's a periodic table, and we find cesium in the first representative column, and so we know the symbol is Cs. And bromine is here in this column, and it's Br. Step 2. We need to identify the ionic charge. For the representative elements, we can read it straight off the periodic table. For the transition metals, we're going to need to use the Roman numeral. So we take a look at cesium. Cesium is in the first tall column, so it has 1 valence electron. So it can either lose 1 electron or gain 7 to reach the octet. Easier to lose 1. So cesium will become 1 plus. Bromine is in the 7th tall column, gain 1 or lose 7, much easier to gain 1, so it becomes negatively charged, so it's bromine 1 minus. Step 3, we need to balance the charges. Cesium is 1 plus, barium is 1 minus. We see the 1 plus is canceled by the 1 minus, so now we can put them together as CSBr. You need to be sure the subscripts are in the lowest whole number ratio. 1 and 1 is a whole number ratio. Can't get any lower than that. So the correct formula for cesium bromide is CSBr. Let's try this again with chromium fluoride. Feel free to try it on your own, but I'm going to run through the steps. Step 1, find the symbols on the periodic table. So we take a look at the periodic table. There's chromium, there's fluorine. We have the symbols. Identify the ionic charge. Chromium is a transition metal. It has the Roman numeral. The Roman numeral is a 3, so we know that chromium has a 3 plus charge. Fluorine is in the 7th tall column. Once again, lose 7 or gain 1. Gaining 1 is easier, so it becomes 1 minus. Now we need to balance the charges. Chromium is a 3 plus. Fluoride is a 1 minus. But you can see that the 1 minus does not cancel out the 3 plus. But if I have 3 fluorides, I now have 3 1 minus charges. 3 plus is canceled by the 3 minus. So we write it like this. We see that we are in the lowest whole number ratio. So chromium 3 fluoride would be written like this. The last example is aluminum oxide, and we're going to use the same rules in the same way. We're going to find the symbols on the periodic table. So we have aluminum here, we have oxygen here. Now we're going to identify the ionic charges for aluminum, which is in the 3rd representative column. lose 3 or gain 5. We're going to lose 3, so aluminum becomes 3 plus. Oxygen is in the 6th column. Lose 6 or gain 2. It's easy to gain 2, so it becomes 2 minus. Now we go and balance the charges, and we see that aluminum at 3 plus is not going to be completely balanced by oxygen 2 minus. But they have a common multiple of 6. So if I multiply the positive 3 by 2, I get a positive 6 charge. I multiply the negative 2 by 3, I get a negative 6 charge. Plus 6 is canceled out by minus 6. So if I have 2 aluminums and 3 oxygens, my charges will balance. So I write this as Al2O3. Once again, we are in the lowest whole number ratio. So that's your final answer. So that's how you go from name to formula for ionic compounds with monoatomic ions. So to review the material, all binary compounds have 2 components. Binary ionic compounds, the 2 components are the cation and the anion. You're always going to say or write the cation first. The positive charge must balance with a negative charge, and the subscripts must be in the lowest whole number ratio. So now you can take a slight rest, review the material, and in the next lecture, we're going to discuss how to go from the formula to the name, once again using monoatomic ions.